Bismillahirrahmanirrahim. Assalamu alaikum, students. Last time we discussed the topic consequences of the Lorentz transformation. Today we will continue with that topic. So I write consequences of the Lorentz transformation. I write continued. In the last lecture, under this heading, we discussed the relativity of time and we derived the relation which is sometimes called time dilation equation, delta t equal delta t naught or under root 1 minus u square by c square. We derived this relation from Lorentz transformation and we justified that this equation is a consequence of Lorentz transformation. Here delta t naught is called proper time. You know all this. Now there are three other consequences. There are three other consequences of the Lorentz transformation that are related with let me write that are related to measurements of time, right? So I will give these three consequences heading 2, number 2. So there are three other consequences of the Lorentz transformation that are related to measurements of time. One is, let me call it A, the relativity of simultaneity. the relativity of simultaneity. Second is the Doppler shift. And third is the twin paradox, right? We will take up them one by one. So today, first we will discuss the relativity of simultaneity. So let us proceed. Listen to me carefully. So first we will discuss the first thing, part A of second, that is the relativity of simultaneity, right? I will draw the figure first. You can continue with the figure and draw the figure with me. Let me use another color here. We complete the figure. Use another color here. This is speed C. Then I have another part of the figure. no. We call this figure 1. This is part A of the figure. This is part B of the figure. Let me check the figure. Okay, figure is okay. Let us go to the explanation. So idea is like this. Suppose S prime has two clocks at rest. Let me write it. Suppose S prime has two clocks at rest located at x1 prime and x2 prime as shown in the figure. This clock 1, this is clock 2, and therefore separated by the interval delta x prime equal to x2 prime minus x1 prime, right? Now a flash of light, this is a flash of light, right? A flash of light emitted from a point midway between the clocks reaches the two clocks simultaneously according to S prime, right? I repeat, write it. A flash of light emitted from a point midway between the clocks reaches the two clocks simultaneously according to S prime as shown in figure 1a, right? That is, a measurement by S prime of the interval between the arrival of the light signals at the two clocks gives delta t prime equal to 0. I repeat and write it. Don't get confused, listen carefully. That is a measurement of by S prime of the interval between the arrival of the light signals at the two clocks gives delta t prime equal to 0. Now consider the situation from the point of view of S. Now consider the situation from the point of view of S relative to whom the frame of S prime, including the clocks. These clocks are in S prime, including the clocks moves with speed u, as shown in figure 1b. You can see S prime is moving to the right with velocity u from the point of view of S, and from the point of view of S prime, S is moving to the left at velocity u, right? Now, as we said, we want to consider the situation from the point of view of S relative to whom the frame of S prime, including the clocks, moves with speed u. Clearly, the light signal reaches clock 1. From the point of view of S, the light signal reaches clock 1 before it reaches clock 2 because of the velocity u. I repeat, from the point of view of S, it is clear that the light signal reaches clock 1 before it reaches clock 2, and thus the arrival of the light signals at the locations of the two clocks is not simultaneous to S. We therefore reach the following conclusion. Let me write the conclusion on the next page. We therefore reach the following conclusion. What is the conclusion. If two observers are in relative motion, in general, they do not agree, they do not agree on whether two events at different, this is important, locations are simultaneous. If one observer finds the finds the two events to be simultaneous, the other does not. As discussed, for S prime, the two events, arrival of flash of light to clock 1 and clock 2, were simultaneous, but for observer S, they were not simultaneous, right? Now, this conclusion also follows from the inverse Lorentz transformation. See how. From inverse Lorentz transformation, we have delta t is equal to gamma times delta t prime plus u delta x prime over c square. Let me name it with some number. We name it and encircle it. We named equation 1. Delta t equal to gamma times delta t prime plus u delta x prime over c square. This is our inverse Lorentz transformation. Now from this equation 1, the same conclusion we have written follows. See how. If in equation 1, delta t prime is 0 and delta x prime is not 0, then delta t is not 0. Simple. What does that mean? That is simple. This conclusion is that mathematical. I repeat, if delta t prime is 0 and delta x prime is not 0, then delta t is not 0. That means if two events which are at different locations according to S prime are simultaneous, then they are not simultaneous according to S, because delta t is not 0. If you put in this equation delta t prime 0, this term will go, but delta x prime is not 0, therefore delta t is not 0, right? Note that this occurs only when the two events occur at different locations according to S prime. That is, when delta x prime is not 0. If the two events occur at the same location and are simultaneous according to S prime, they are simultaneous to S as well. Because if delta x prime is 0, delta t prime is 0, then delta t is also 0. So let me write it. This is important. If the two events occur at the same location and are simultaneous according to S prime, they are simultaneous to S as well. This was about relativity of simultaneity. I hope you got it. Now I will take up the Doppler shift B. Let me change the color. The Doppler shift. The Doppler shift, we have to here discuss actually the Doppler shift for light waves. We need to remember you might be knowing the Doppler shift. I will explain it. The Doppler shift for sound waves is different from the Doppler shift for light waves. We need to remember it. The Doppler shift for sound waves is different from the Doppler shift for light waves. Why? Sound is a mechanical wave. It needs medium to propagate, but light wave is an electromagnetic wave. It does not require any medium to move. Because of that distinction, the Doppler shift for these two kinds of waves is different. So first, I will refresh your memory for Doppler shift for sound. You have done it in previous classes. I will refresh that. You know, sound wave is a mechanical wave. It requires a medium to propagate from one point to another point. And Doppler was basically a person, Christian Johann Doppler. And this effect is after his name. What is this effect? First, I will write, we call it the Doppler effect for sound. Remember, when a listener is in motion toward a stationary source of sound, the frequency of the sound heard is higher than when the listener is at rest. If the listener is in motion away from the stationary source, a lower frequency is heard. We obtain similar results when the source is in motion toward or away from a stationary listener. You might have experienced it that the frequency of the whistle of a locomotive or the siren of a fire engine is higher when the source is approaching the hearer or listener than when it has passed and is receding. So this effect in the frequency due to the motion between the source of sound and the observer of sound or source or listener of sound, this effect in change in frequency due to that relative motion is called Doppler effect for sound. I will write the general expression. It has many cases. You have done it in your class 11th. If source is at rest, then there can be two cases. Observer can move towards the stationary source or away from the source. If observer moves towards the stationary source, frequency will increase. If it moves away from the stationary source, frequency would decrease. Then you can have observer at rest and source moving. Source can move towards stationary observer or away. Accordingly, there will be two cases. And third possibility is both source and observer can move towards each other or away from each other, right? Now, first, when we talk of motion, it is related to something, some reference frame. I will write first the equation, then I will discuss. So the general equation is written as the general equation is nu prime is equal to nu O times, let me write it in bracket, V plus minus VO V minus plus Vs. Let me name it equation first. Nu prime is equal to nu V plus minus Vo over V minus plus Vs. I will explain all the cases are contained in this equation. Incidentally, let me call it equation 2 because we have already named equation 1 in this lecture. So this is my equation 2. What is nu? Nu is called actual frequency of sound wave. What is nu prime? It is the actual frequency. By actual, I mean the frequency which is heard by the listener or observer. So it is sometimes called, or called in most books as apparent frequency of sound wave, right? So nu prime, you know now it's apparent frequency of sound wave. Nu is actual frequency of sound wave. What is V? V is the velocity of sound wave in the medium. V is the velocity of sound in the medium in which sound wave is propagating. What is VO? VO is the velocity of observer or listener then we have another thing, Vs is velocity of the source of the sound wave, right? Nu is actual frequency of sound wave. Nu prime is apparent frequency of sound wave. V is velocity of sound in the medium. Vo is velocity of observer or listener. Vs is velocity of the source of the sound wave. Now all these velocities, let me use another color. All these velocities, V, Vo, Vs, are with respect, all these velocities are measured with respect to a reference frame at rest in the medium. At rest in the medium. This is important. So I repeat, all these velocities are measured with respect to a reference frame at rest in the medium through which the sound travels. is understood in the medium through which the sound travels, right? And this equation which we have written, equation 2, is valid for the spatial case in which the source and observer move along the line joining them. I write it somewhere. Assuming the source and observer move along the line joining them, right? So we are observing the motion relative to the reference frame attached to the medium. That reference frame is at rest and attached to the medium through which the sound wave is traveling, right? Now we can discuss the cases. If source is at rest, or let me take if there is no relative motion, if there is no relative motion, that is if Vs is 0 and Vo is 0, what will happen to equation 2? Vo 0, no velocity for observer, no velocity for source. So these two terms will become 0. It will become V by V, which is 1. So you will get nu prime equal to nu. This one case. So when there is no motion, apparent frequency is equal to actual frequency. There is no Doppler effect. No Doppler effect, right? Now, if Vo is 0 and Vs is not equal to 0, that means source is moving, observer is at rest, then we are doing it from equation 2, which is our general equation, this one. Then from equation 2, we have nu prime is equal to nu, what is inside the bracket? I have V plus minus Vo over V minus plus Vs. So my Vo is 0. So I have V over V minus plus Vs, right? V over V minus plus Vs. When there is observer is stationary. Now see, minus and plus, there are two possibilities. One possibility is that source is approaching the stationary observer, right? If source is approaching the stationary observer, then what will happen? Frequency will increase. Nu prime will be greater than nu. That is possible when denominator will decrease. So you have to take minus sign. That means I will use another color. This minus sign is for source approaching case. That means source approaching the stationary observer. Minus sign is for that, because when source approaches the stationary observer, nu dash should increase, denominator should decrease here. Then let me use now another color. Plus sign, you understand now. Plus sign is for source receding case. That means when source recedes from the stationary observer, nu prime will be less than nu. That is possible when denominator will increase. That's you have to take the plus sign, right? So let me name these equations. This I call 3, no relative motion, no Doppler effect. So this I call 4. It contains 2 cases. This is for what? Stationary observer and moving source, right? Stationary observer and moving source. Vs is non-zero, that means source is moving. Vo is 0, that means observer is stationary. Now take another case. These are 4. Now if Vo is not 0 and Vs is equal to 0, then from equation 2 we have, now Vo is non-zero, Vs is 0. That means now source is stationary source, moving observer, stationary source, Vs 0, moving observer, Vo not 0. So what is the equation? Nu prime is equal to nu. What is inside the bracket? Vo is non-zero, so we have V plus minus Vo over V. You can check. V plus minus Vo over V. V plus minus Vo over V, because Vs is 0. Right? Now again, let me name it first. This is which equation? What is the number of this equation? It is 5. It's equation 5. As we have said that now source is stationary, observer is moving. But there are 2 possibilities. If observer moves towards stationary source, frequency increases, numerator must increase. So for that you have to take the plus sign. So let me use this color. So this plus sign is for which case? Plus sign is for observer moving towards source, stationary source, right? And minus is because when observer recedes from the source, which is stationary, frequency should decrease, so numerator must decrease. Oh, let me use another color for this one. So this negative sign you have to take for which case? For observer receding from source. So if observer recedes from source, this is minus sign is taken, nu prime will be less than mu. Numerator is decreasing. If observer moves towards stationary source, you have to take the plus sign, right? Then we have if both are in motion. That's our main equation. I will go directly to that. Now when both are moving, VO is non-zero, VS is non-zero. Then there will be a greater effect in nu prime compared to when one is moving. Now what you have to do, if observer and source both are approaching towards each other, then what you have to take? There will be bigger effect, bigger increase in frequency. So you have to take plus sign in the numerator, minus sign in the denominator. You both are approaching. I should write, or I will write it separately. If both are moving, that is Vs not equal to 0 and Vo not equal to 0. We have nu prime equal to nu V plus minus Vo over V minus plus Vs. I have written it once again, question 3, in order to make it clear. V plus minus Vo over V minus plus Vs, right? So now there are two cases. If the source and observer are approaching each other, then plus sign in the numerator, minus sign in the denominator. Because there will be bigger increase if source and observer are approaching each other. Numerator will increase, that will have increasing effect on frequency. Denominator will decrease, that will have also increased. I will use second color. If the source and observer are receding from each other, then there will be bigger decrease in the frequency. The numerator will decrease. In the numerator, you have to take the minus sign, and the denominator, it will increase. You have to take the plus sign, right? I repeat, if the source and observer are receding from each other, then frequency will decrease. You have to decrease denominator and numerator, sorry, take the minus sign and increase the denominator in order to have decreasing effect on frequency, and take plus sign in the denominator. So all cases I have discussed. This was the Doppler effect for sound. In the next lecture, we have to discuss the Doppler effect for light waves. That is different, as we will discuss. Go through all the video lectures. Don't waste your time. This is all for today. And don't forget to subscribe and like my channel. Thank you. God bless you. Assalamu alaikum.